Today we're going to look at stretches and compressions of sinusoidal functions. Yesterday we looked at translation, so move things left, right, up, down. It never changed the shape of our function. All it does is change where it lay on the graph. Today we are going to change the shape. It's going to be vertically and or horizontally stretched or compressed. So it might look twice as big or half as big or twice as tall and twice as long, things like that. The first thing we're going to look at, the easier ones, was what happens when we change our a value, that number out front. Okay, whatever value goes here affects your vertical size of your graph. It affects your amplitude to be sure. Okay. The bigger that number is, the more your graph gets stretched vertically. So for example, if a was at 10, if we had y equals 10 sine x, our graph would be 10 times as tall vertically. Our amplitude would now be 10. Our general rule is any value bigger than 1 will stretch your graph vertically. Anything less than 1, so a fraction, a half, a quarter, a fifth, will compress the graph vertically. And negatives actually reflect the graph. So if we were to end up with something like y equals negative 3 sine x, the negative sign would reflect it. It would go down instead of up first. And the 3 would be a vertical stretch. So you'd actually have two things going on there. Okay. The nice thing about the a value is, as we said earlier, a is your amplitude. And because we're not moving things up or down, it also gives you your max and your min values. To graph one of these things, the easiest way is to take your table of values and multiply the y's, because y is your vertical direction, by the a value. That's just what it says down here at the bottom. I take the y's and multiply by a. Okay, so let's try a few. Okay, I want to look at these graphs, determine the amplitude period, and make a table of values to sketch. Well, there's the value out front, a. A is my amplitude, so in this case, my amplitude is 3. The period we said is 360 divided by k a couple of days ago. Well, we haven't done anything there yet. K is still right here, right? It's 1. So 360 over 1, or just 360. We haven't done anything horizontally to these graphs. To graph these, here's our table of values. So let's think back to a basic sine curve. X and Y, 0, 90, 180, 270, 360, 0, 1, 0, negative 1, 0. I want to stretch my graph by a factor of 3, a vertical stretch by 3. So I'm going to take my y's and times them by 3. I'll get exactly the same x values. I'm not going to rewrite them, just write down the y values this time. I got 0, 3, 0, negative 3, 0. So the same graph, 0, 0, 90 and 3, but it's been stretched. It used to be 90 and 1, 180 and 0, 270 and negative 3, and 360 and 0. So it still looks like a sine curve. It's just a lot more stretched out now. Okay. Try the second one. The amplitude of this. Well, the amplitude is the number out front. So our amplitude would be 1/2 or 0.5. Again, we haven't changed things horizontally at all. So the period is still 360. The k value right here is 1, right? We haven't done anything to that. And making a cos curve this time. 0, 90, 180, 270. Hopefully by now we're getting pretty good at drawing out these tables. I promise they will get more complicated later as we go, but right now they should be pretty simple because we want to keep them pretty simple. Okay, what are we doing this time? We're multiplying our y's by 0.5. So 0.5 y. X stays the same, but now we get 0.5 for y. Can't really fit that in there. 0, negative 0.5, 0, and 0.5. So thinking about this graph, it was a cos curve. It still looks like a cos curve, except for instead of being as tall as it used to be, it's now half as tall as it used to be. It's been vertically compressed. And there's our curve. Okay, half as big as it used to be. That's all you can do with things vertical. And if we look at the horizontal ones, we start stretching and compressing things horizontally. What we're doing is we're changing the period. We're changing how many cycles can happen in the same amount of space. To show this, we put a k value, as I talked about before, between the sine and the x, or the cos and the x. Okay, x's kind of do things backwards. So in this case, if k is larger than 1, we actually compress. And the reason why is, remember, think about our period. Period is 360 divided by k. The bigger the k, the smaller the period. It's a division happening here. Now the key there is, okay, if it's larger than 1, we're going to compress. If it's less than 1, we're going to stretch. So for example, if I saw y equal cos of 1/2 x, and that would actually be a stretch by a factor of 2. In the part that's on the bottom ready, or think about flipping up the fraction upside down. As we said before, period is given by 360 over k. And if I want to figure out my new table values this time, I'm going to divide, key there, we're dividing this time, right? We're doing the opposite, the x values by whatever k happens to be. Okay, so we take a look at this one. I determine the amplitude, period, and the new table values. We're not going to draw them out this time, we'll just make tables, make it a little bit faster for us. Okay, so my amplitude. Amplitude is the number out front, the a value out here. Oh, there's nothing there, so it must be a 1. The period. Period is 360 divided by k. K is that number. So 360 divided by 4 makes 90. Yeah, I've compressed this thing. Determine determine the new table. Well, okay, let's make a sine curve real quick here. So 0, 90, 180, 270, 360, 0, 1, 0, negative 1, 0. What are we doing? We didn't do anything to the y's, no vertical stretch or compress. But the x's, we're dividing by 4. Whatever's here goes here, right? Same thing. So my new x's are now going to be 0 divided by 4, still 0. 90 divided by 4, that's 22.5. 180 divided by 4 would be 45. Then 67.5. Then 90. And if you stop and think about your period, starts at 0, ends at 90, matches what our period says it should be. Our y's have not changed, didn't do anything to those at all. They stayed the same. How would I describe this? I would say this is a horizontal compression by 4. And we're done. Okay, you guys try the second one. So you can figure it out, what's going on there. Your amplitude is 1. The period is 360 divided by 0.5, which comes up to 720. So it's been stretched. In our old table, we're looking at a cos curve, 0, 90, 180, 270, 360, 1, 0, negative 1, 0, 1. What are we doing to that? We're taking the x's and we're dividing them by 0.5. Again, what's here goes here, right? Same things. Okay, our y's stayed the same. Let's write those in now. 1, 0, negative 1, 0, 1. 0 divided by 0.5, still 0. 90 divided by 0.5 is actually 180. When you divide by 0.5, you're basically doubling, right? 180 divided by 0.5 is 360. 270 would be 540. And 360 becomes 720. And again, our period, our starting point, so our end point is 720 degrees apart, which matches our period. What would we say in word? We'd say this is a horizontal, sorry, not compression, a horizontal stretch by 2. Twice as big as it used to be. Okay, last 2. Give them a try. There's more than one thing going on here at a time. Give them a try. And so we have an amplitude of 2. A period of 360 over 2, so 180. It's a sine curve. X, Y, 0, 90, 180, 270, 360, 1, 0, negative 1, 0. Okay, what are we doing? The Y things. Well, this is a Y thing. It's a vertical stretch by 2. And this is an X thing right here, right? So we got to take the X's and divide by 2. So we've done 2 things at once. Our new X's. 9 divided by 2 is 45. And 90. And 135. And 180. Our Y's times 2, 0, 2, 0, negative 2, 0. Okay, what have we done in words? Two things. We've done a vertical stretch, that's the y ones, the amplitude, by 2, and a horizontal compression by half, right? It's half the size it used to be. Okay, last one. Give it a try. Something weird going on in this one. We have a negative sign out front. Talk about that. Our amplitude. It's the value in front. The value in front is a 1. Okay, yes, there's a negative sign there, but remember we said a negative sign reflects things. It doesn't actually change the size at all. It doesn't actually become part of amplitude at all. It just tells me the direction I'm going to go. The period in this case would be 360. I can't divide 1/3 into decimals, so 0.3333. It goes on and on forever, right? So I'm going to actually use 1/3, which is the same thing as saying 360 times 3. When you divide by 1/3, you're actually multiplying by 3. So our period is 1080 degrees. Okay, it's a sine curve again. If you want to, just take the table we already made. It's the same one that's over here. We'll use that one to do our math. Okay, what are we doing to it? We're taking our y's. Y's are these things. We didn't change the number, we changed the sign. So we've got to change the sign of your y's. Take the negative of your y's. And what do we do to the x's? We divide it by 1/3. But we also said that's the same thing as multiplying by 3. Okay, it works just the same. So let's multiply our x's by 3. What do we get? Remember, we're working with this table over here, the initial sign table, right? So 0, then 270, then 540, then 810, then 1080. And there's all your x's. Your y's, we're taking the negative of them, remember? So 0 is still 0. The negative 1 will be negative 1. Then 0, then 1, then 0. So this graph would go down first, then back up, instead of vice versa. It usually does. In words, what would we say is happening here? We'd say there's a reflection vertically, and we'd say there's a horizontal stretch by 3. Okay, that takes us through the first 2 pages.